There are many different attributes you can use to configure your layout. Each layout type has its own specific attributes, but there are a few basic ones that are used across all the different types. Here are 3 basic attributes that I am going to cover: size, margin versus padding, and gravity. Let's use Hello World as an example to see how we can configure size in Android. This is the XML code for Hello World. We have a parent called Linear Layout. Linear Layout allows you to put views inside and put them either horizontally or vertically. Right now, we only have one single view inside, so it doesn't really matter whether we say horizontal or vertical. In our case, the linear layout takes match parent as both the width and the height. This means that it wants to take as much space as the parent is, which is the whole screen. Looking at the child view, the text view, it says the width is match parent and the height is wrap content. In this case, it will again take as much width as there is available, but the height is only going to be as much as the string Hello World needs. How does it look like? Well, if you look at the result like that, you can't really tell whether the parent view is taking the whole width and the whole height, and then the child text view is taking only as much height as it needs. One trick to show that is to change the background color. Here, I have added the attribute Android:_background, which will change the color of the linear layout parent to be blue. And indeed, it takes up the whole screen. How about the text view? Again, using the Android:_background trick, we can see that indeed, the width being match parent is taking up as much space as the parent provides, and the height being wrap content is only going to take as much space as the word Hello World needs. So here, we have width as match parent and height as wrap content for the text view. How about we also change the width to be wrap content? How would it look like? This is how it looks like. With wrap content on both the width and the height, the text view only takes as much space as it needs. Besides match parent and wrap content, you can also give Android a specific size. Here, I have changed the height to be 100 dp, and this is how it looks like. You may be wondering, what is dp? I usually see px for pixels when I specify dimensions like that. dp stands for density independent pixel, and this is a way for Android to deal with multiple kinds of devices with different screen densities. Here is how you translate dp to px, the pixel values for displaying on screen. You take the dp, device independent pixel value, and multiply it by density. To compute the density, we have to go a little bit into the history of Android. When Android was first launched, it was on a device with 160 dpi. Later, there are devices with a different density of a different dpi that came out, and Android needed a way to specify dimensions of screen elements so that the visual size stays the same even though the number of pixels used to display it is different. This is why 160 became the base value for density, and Android categorizes the screen densities into different buckets. 160 became the reference point and is assigned a value of 1. We call those devices MDPI devices, so F standing for medium density. Besides MDPI, on the low end, we have LDPI, which is of half density with a multiply factor of 0.5. The next bucket is HDPI, which stands for high density, and the multiplicative factor is 1.5. Devices with even higher screen pixel densities are assigned XH DPI, which gets a density multiplicative factor of 2. Nowadays, there are devices with even higher densities of XXH DPI. Let's look at what happens when we have a device of XH DPI density, or in other words, of factor 2 double density. Here, we are looking at two devices, one with normal density and one with double density. Notice that the double density device has more pixels per physical area than the normal density one. If we told our app to take 1 px for our view, it maps directly to a physical pixel. So for a normal density device, it will take a larger area than a double density device. This is not what we want because it will shrink our view without us wanting it to. To solve this problem, change it to 1 dp. This way, when Android is loaded on a double density device, the system will automatically multiply the dp unit with the density to come up with a final pixel unit. 1 dp get multiplied into 2 px when our app is run on a double density device. This way, the physical appearance of your view will be of the same size, even though the density of the screen is different.